Okay, so the last thing I want to talk about for this lesson is the relationship between hypothesis testing and confidence intervals. Because when you reject a null hypothesis, it turns out that that's the same thing as if the null value is not inside the interval. And if you fail to reject null hypothesis, that's the same thing as saying the null value is inside the interval. So there is a closer relationship between confidence intervals and significance tests. And specifically, if a point estimate is significantly different from the null value at the 0.05 level, and what that means is that the p-value is less than 0.05, then the 95% confidence interval will not contain that value, that null value. At the same time, if it's not significantly different from the null value, so if the p-value is more than 0.05, then the null value will be inside that interval. So essentially, any confidence intervals are ranges of plausible values. So any value inside the interval is considered to be plausible. So, whereas values that are outside the interval are considered to be not plausible. Now, if your null value is inside, that would be the same thing as saying fail to reject, because if the null value is inside the interval, then the null value is plausible. So that means the null hypothesis is plausible. We would fail to reject. If the null value is outside, then that means the null value is not plausible, which means that the null hypothesis is probably not true and we should go with the alternative. So what we're looking for is the null value inside the interval or outside? As for the point estimate is always going to be the center of the interval because the intervals are built around that point estimate. But what we're looking for is where the null value fits. So looking at non-significant effects in terms of confidence intervals makes clear why the null hypothesis should not be accepted when it is not rejected. Because every value in the interval is a plausible value of that parameter. If a null value is in the interval, then the null value is plausible and cannot be rejected. However, there's an infinite number of other values in that interval that also can't be rejected either. So that means that the null hypothesis is plausible, but there are other values that are also plausible. All right, let's start with an example. The null hypothesis for an experiment is that the mean test score is 20. If the 95% confidence interval is from 18 to 24, can you reject the null hypothesis? Well, the main thing in terms of whether you want to reject or not is you take that null value of 20 and see, is it inside or outside the interval? In this case, it's inside, so that means the null value is plausible, and so we would fail to reject. So the question, can you reject null hypothesis? No. The confidence interval shows 20 is a plausible value of the true mean. Okay. Here, which of these 95% confidence intervals represents samples that are significantly different from 0? So I'll select all that apply. That first one, negative 0.15 to negative 0.03, you notice that the range of plausible values is entirely negative. So that would mean that 0 would be outside, we would reject. So part A would be one that is significantly different from 0. Part B, negative 0.15 to positive 0.03, 0 is inside, so we would fail to reject. Part C, negative 0.03 to positive 0.15, again, 0 would be inside, we would fail to reject. Part D, 0.03 to 0.15, those are completely positive numbers, so 0 would be outside. We would reject on that one as well. So if you want to see which ones are significantly different from 0, you look for the ones that are either all negative or all positive. All right, true or false? If a 95% confidence interval contains 0, so will the 99% confidence interval. Well, recall that if you want to be 99% confident, you need to be wider than the 95%. You need a larger net. And in fact, if 95% contains 0, 99% would, because 99% will cover everything that 95% covers, plus some. So if a 95% confidence interval contains 0, so will the 99% confidence interval. That's true. Again, here's the reason. The 99% confidence interval contains all the values that 95% has, but it extends farther on both ends and has other values as well. So if something is not significant at 0.05 level, it is also not significant at the 0.01 level. What that means is that if it's not significant, that means if the p-value is larger than 0.05, then it's going to be larger than 0.01 as well. So if the p-value is larger than 5%, it's also larger than 1%. What about this one? If a 95% confidence interval contains 0, what about a 90% confidence interval? In this case, 90% are completely inside the 95%, so it might have 0 or it might not. So this is not necessarily true for the 90% to have 0 as well. The 90% confidence interval will be inside the 95%, so it is possible to be inside the 95%, but not in the 90%. That is, maybe it's true the p-value is more than 0.05, but that could still be less than 0.1 as well.